Hello and good afternoon. Welcome to today's Heat Trace series number 4 seminar. This will wrap up this segment. So today we'll be talking about installation tips and troubleshooting. So hopefully you guys are ready to sit down and have a quick 30-minute seminar and get some updates. One quick item to review, and I did this from the previous ones as you might remember, but if you have any audio or video problems, there is a reconnect button at the top. On the right hand side you will see 4 or 3 dots in a red box. You can click that and get into a chat window if you want to send any messages, questions, or just to say hello. Please feel free to do that. All right, so here's on the agenda today. We have, of course, our quick introductions, installation tips for specific to heat trace on piping. So we'll go into that, and that'll both apply to industrial as well as commercial. Then we'll get into some installation tips specific more to the snow melt, in-floor, and ice stop applications. And we'll also show some online videos that will be helpful for those who don't like to look at manuals. And then we'll also have troubleshooting guides, and we'll go through some of those tips as well. So hello and welcome. My name is Melissa. I am with the Dale Prentice Company. As you can see, I've been working on the site. This is just a good safety picture. We are going to be talking a lot about installation today, and safety is very important when it comes to any installations or troubleshooting. So we will touch on some of those basics. I have been with the Dale Prentice Company now for over 25 years, mostly doing design work through the years, both inside and outside. But currently, as in the last 9 years, I've been more doing the outside sales engineering and field technical support. Dale Prentice Company, we are a local Michigan-based company. We offer solutions in the marketplace relative to safety, things like heat tracing that we've been talking about, but also other things like gas detection systems or overprotection safety devices like relief valves, rupture discs, as well as valve automation and controls. And then we've also got a team of field services group that does repair work and testing and things of that nature for relief valves and valve automation. All right, so let's get right into it. Installation tips. So I say look at the book kind of tongue-in-cheek because, you know, when we ship out materials, we always, most of the time, there has been occasions where maybe it didn't come in the box, but on most occasions, the material gets shipped with a little booklet. This booklet is actually shaped to be very handy to be able to stick in a back pocket. It was designed that way on purpose with the field in mind, so it could go with the person in the field as needed. In this instruction manual, there is a lot of good basic information as well as some very detailed information, which we'll talk about here in a minute. Every installation guidebook looks a little bit differently. It's going to talk about different parts and pieces and things of that nature, but the main principles are going to apply. You know, what do you need to know about being safe, how to install it safely, all the way through to the end where you get into the installation measuring and other tests, how to do those tests, as well as there's places in the back of each book that have a form that you can literally fill out, so the owner will have a installed startup sheet. So they'll have all that information categorized for their project. So it's a nice handy book. However, some people aren't interested in books, and I get that. It's sometimes hard to do. And so we also have some online videos that are available. The quickest way to find some of these videos is to go to the YouTube and go to nVent Thermal. Search nVent Thermal. The first thing that's going to pop up is going to be this nVent. If you click on that, you're going to see they have hundreds and hundreds of videos in here. Some may be relevant to your application, some maybe not. In what we're talking about right now, it's going to be around heat trace for process temperature maintenance. So they go into, if you need to know how to install an end seal, a lighted end seal, power connection kit, those kinds of things. And in fact, I'm going to play a short video so you can just see what that looks like.
Installing nVent Raychem JBS 100. The nVent Raychem JBS 100 is a power connection kit for a single heat tracing cable. First, allow about 24 inches, 600 millimeters of heating cable for installation. Cut the heating cable end at about 45 degrees. Apply lubricant for easier insertion into the stand. Push 18 inches, 450 millimeters of heating cable through the stand. Now, square off the cable end with a 90-degree cut, but do not attach to the pipe yet, and proceed to stripping the end of the cable. When stripping Raychem self-regulating heating cables, you should be aware that conventional cable stripping techniques are not appropriate. Let's look at a...
So that's just a short synopsis of the videos that are online accessible to you. And so please feel free to check those out on the YouTube. Let me go back to my webinar. Okay, installation tips. So don't make these common mistakes. I'm going through these one by one. These are all listed in the installation guides in different areas, but these are the most common things when I go to the field to do a commissioning or a startup that I find can occur. So the first thing is, if you have a metal pipe, we install the glass tape around the diameter of the pipe. When we have a plastic pipe, however, we actually use the aluminum tape to help with the heat dispersion of the heat trace cable, and so it needs to be installed over the top and in parallel over the heating cable. So much different method, and if you don't apply it with the aluminum tape, you can not allow for as much heat to get into that plastic pipe, and it could cause that pipe to freeze. Installing heat trace on the outside of the bends. So anytime you have a 90-degree elbow, and when you get, it's really relevant when you get above 2-inch size pipes. Your heat losses are going to be much larger in the outer surface of an elbow. And if you only install the heat trace on the inside of an elbow, you could again be not applying enough heat, enough watts in that area, and cause a potential freezing at that elbow joint. Give extras. You know, this is by far one of the biggest things that comes back to bite people if they don't give themselves enough extras. As an example, when you're doing a T connection, if you come in to a T where you have 3 heat trace sections coming into one unit, if something ever happens to that connection system or the heat trace cable, that it requires you to remove it and try to reinstall it. If you don't have any extra play with heat trace in that section, it may require you to actually strip back a lot more cable, or having to introduce an extra splice kit as an example to try to compensate for that. So anything extras, valves, this particular image shows in a sprinkler application where you might have a sprinkler head with a sprig. This is one section where you want to have extra cable. But any valves, any pumps, any big obstacles, pipe supports, and again, all of this is in our installation manual, but it's something that is missed very, very commonly. And again, these are areas that will come back to bite you, that either you have to replace it because it's frozen, or if you do have to replace the connection kit, you don't have enough cable to work with. Megger testing the cables. This is an installation resistance test that I'm referring to. It is in the back of the installation manual. In the back of the manual, it does talk about 3 different times that this testing should occur. It should occur when you receive the reel of cable. It should also be done when you've installed it. Say if it's on a pipe, maybe you've installed it on the pipe, but it's before the insulation is put on. And then the 3rd time is the complete final one. After the insulation and components are installed, you do that 3rd testing. And you do have a spot in the book that you can write all of these results down. These are very important. If you ever have to come back on a different contractor who's maybe come back and maybe they installed the insulation with a screw, a fastener, and accidentally screwed into a cable, you now have those results written down, and you have something to back you and go back on and say, no, this tested fine. Here's where the problem happened. Also take note that there are different voltages that you need to test at. Most cables are at 3 voltages, 500, 1000, and 2500 volts DC. There are some cables that only require 2 voltages. So again, refer back to your installation manual for those bits of information. And then finally, don't leave the cables exposed. There have been so many occasions where I get the call saying, we've got a problem, the breaker keeps tripping or it's not passing the Megger test. And what happens is if the ends are exposed, even if it's in a dry environment, if it's left overnight or left in an environment that there's any kind of moisture, that the cable ends can wick up that water, and it can cause potential problems with your testing. If you do ever come into that situation, sometimes you can simply cut off a couple inches at the end, retest it, and see if you've been able to clear. All right, installation tips for snow melting and in-floor systems. So with snow melting and in-floor, every project is different. You know, the layout and the spacing for the cables can vary greatly. So please don't go based off of an installation manual only. Go based off of the actual project design, or if there were layout drawings provided, go based off of those. I do highly recommend, instead of trying to lay out the cable right away, if you want to use a spray can or even a string and try to create that pattern, that just helps the guys to have a pattern for them to mark and go and efficiently install that cable, so that at the end of it, you don't figure out that you've got an extra 50 foot and you don't know what to do with it, or you may be short 20 feet and now you don't know what to do. Sometimes creating that pattern ahead of time will allow for that not to happen. Ensure that there are no sharp objects or ends. I have had projects, and in fact, every time I go to a job site to do my commissioning or pre-checks, before a concrete pour. This is one thing that I'm very adamant about, making sure your cables are secured with the amount of cable ties that are needed, and that there are no cables that are near any of the rebar or mesh where the ends are cut off or sharp. I have had projects that has unfortunately been an issue, and it can cause wear and tear on that cable. So you want to be very cognizant of that. Providing heating evenly is our goal, especially when it comes to snow melt. So what that means is if you have cables that are on a mesh that are lifted up with chairs that are elevated to an exact dimension, so typically we recommend about 1.5 to 2 inches below the surface, that's very critical that that's as even as you can get in a surface area. If you have a section that the cable is all the way down 4 or 5 inches down to the ground, or you have another area that's 1 inch or less onto the top of the surface, you can get a lot of variations in your melting. You can also cause concrete to prematurely buckle or even bust. So we do want to just make sure that you have an even level on excuse me, on those areas. Again, same thing applies. Megger testing, installation testing is very, very critical. Make sure you look at the manual, make sure you do that on all 3 different occasions and at the voltages that apply to the product. And then lastly, I'd say this again, because this is probably the #1 thing that I find becomes a problem, is when water gets into the cable, if it has not been secured, even if it's secured with electrical tape at the ends, is better than leaving it open to atmosphere and allowing water to get in. Installation tips for ice stops. So ice stop is the roof and gutter. I say verify layout because you don't know, in some cases, is this project just to throw the cable in the gutter? Or are we supposed to apply this up on the roof edge itself? And if we're applying it on the roof edge, how far are we supposed to go up and down on that particular roof? All those things are very important to understand. So I do advise making sure you know what that layout looks like and how you use all the components. In some applications, we have rim metal products that might be used. In other products, we might have clips. So all of those components can be used in a variety of ways. So again, if you don't have a layout drawing or if you have any questions on that, please make sure to contact your local representative. Okay, secondly, ensure that all the cables are secured, and not just on the downspouts, but if you have any other ups and downs vertically, or if you're doing multiple cables in a gutter, you want to make sure that they are secured so they don't come together as much as possible so that they're effective. But the reason why we want it secured, especially in a downspout, is over time, ice and snow can have a very impactful pressure force, and it can actually pull the cable down where you don't want it to be pulled. So supporting that is very, very important. Installation with drip loops or condensation drain points. I find this problem most often with the ice stop systems only because of the application is outdoors. But this also goes back to pipe heat trace. So anytime you have heating cable, you want to make sure your power connections and your wiring aren't going to allow water to continue the pathway from the cable directly into your connection kit. Or for the power wiring, if you're talking about especially power wiring in a conduit, you want to make sure before that conduit gets into your junction box, into your power connection source, that you don't have water potentially coming directly into that box. So we do have JB drain plugs as an option, or there's many other drain plug options, but please just make sure you're cognizant of that. If water starts to get into those junction boxes, a lot of them are NEMA 4X rated, which does mean that they're sealed tight. Once water gets in, it's actually very hard for water to get back out in some cases. Again, Megger testing the cable. I can't express this enough. This is very, very important, and making sure you follow the manual and guidelines to do that. And don't leave the cable exposed. Again, this is another very important tip, which is why I'm putting it on all these slides. All right, let's get into some troubleshooting. Troubleshooting, I find oftentimes if you have a system that is working fine, it's been working, no problems with it, and then all of a sudden one day out of the blue, it's either blowing a breaker or it's tripping because of ground fault, I highly suggest looking at this job site as a whole, looking at what other work is being done in the area. In a lot of cases, that's going to get you directly to potentially where that problem is. Secondly, checking for any potential damages that are visual are the best, quickest means if you have access to look at the cables. I have had, unfortunately, squirrels and mice and birds get into cables, and if they can chew, they will chew. So that's been a potential problem. Insulation damage. So if the insulation is not a water resistant type, and water does get into the insulation, it will render that insulation useless. When it does that, the heat trace will apply the heat as it normally does. So you're not going to necessarily have a breaker going off, but you may have a frozen pipe because your insulation is no longer keeping that heat where it needs to keep it into the pipe, or any other water type damage that might have occurred, especially near connections or junction boxes. So that's the first thing I always have them look at is, other than the obvious first 2 points, looking at the connections first. Any signs of moisture, any loose connections inside of T's, power connections, end seals, any of those are going to be the first place that I'm going to tell you to start checking. And then again, you go back to, let's test the cable out. If you have done your job on the startup, you should have a record of what the installation numbers look like. So now you can compare that record and say, okay, how does this Megger test now compare? Is it greatly different? Is it the same or similar? Is there a problem? And you can go from there. And then you go to the isolations. You know, isolating, is it just the cable itself? Okay, it's not the cable. It must be in a component somewhere. Isolate the components. And then you kind of work your way backwards into isolating your controllers. And then finally, is it a circuit breaker problem or is it a power problem? And I could probably circle back to the next most logical thing when I get a call is someone turned the breaker off in the off season. They forgot to turn the breaker back on when it was during the season. So that's another potential you need to look at. So for any further troubleshooting, please use your local support. We have guys who are all over the state of Michigan. Our Oak Park warehouse facility has a lot of good local inventory as well, that if you need any parts and pieces to try to replace out. So please feel free to give us a call and we will certainly support you. So for those who missed our first series 1, 2, or 3, they are available for replay for a time being. You can get to those by registering it through the prentisco.com/training link. You can also go, I'm going to show you our website real quick. So this is the Prentisco website, and for further information specific to our heat trace, we do have a series of videos that are available anytime you'd like to come in and take a look when you have a few minutes. on specific points of the heat trace systems. So if this would be of interest to you, again, prenticeco.com, and then under the offerings, and then the electric heat tracing and controls, and you'll get right there. All right. Thank you guys for your time. I appreciate it. Hopefully you've been able to have a quick lunch break and learn a few things about heat trace installation. We've gone through a lot of different, as you can see from the different series, we've gone through a lot of different heat trace points, whether it's the selection, the estimating, different applications that we can help solve. There's always new and different things that we are learning and applications that we can solve. So please feel free to reach out to any of us at the Dale Prentice Company. You can see the number at the bottom of the screen, 800-536-4700, or feel free to email. The general email is sales@prenticeco.com, or again, you can email me directly at my email address on the screen. So thank you very much. I appreciate your time. And if you do have any questions, again, feel free to put that in the chat box. And if you don't get a response back, you should get a response via email in the very near future. So without further ado, thank you very much. Appreciate your time. Have a good one.